Assalamu alaikum students, hope you all will be fine. Today we start a new unit number 2, real number. And in real number we learn about irrational number, rational number, real numbers, terminating and non-terminating fractions, perfect square, squares of natural number, square of a common fraction, perfect square by prime factorization and division method, and the rule of perfect square, real life problem involving square root, cube and perfect cubes, cube roots, and then properties of cube of a number. The first topic is irrational number, the number which cannot be written in the form of p by q, where p and q belongs to z, which are the integers, and q not equal to 0 are called irrational number. There is no such irrational number whose square is 2. Therefore, square root of 2 is not a rational number. Similarly, under root 2, under root 5 by 7 and under root 2 by 3 is not rational number. They are called irrational numbers. The set of irrational number is denoted by q. It can also be defined as a number whose decimal representation is non-terminating and non-recurring is called irrational number. For example, under root 2 equals to 1.4142135 and infinite. It means that this is an irrational number because this is not right in the form of p by q and this is an infinite value. Under root 3 equals to 1.7320500870 and so on. This is also an infinite value and not written in the form of p by q. Under root 37 is also an infinite and not written in the form of p by q. Under root 8 equals to 2 under root 2. We take under root 2 and then multiply it by with 2. The value is 2.828 and then so on. It is also infinite value and not written in the form of p by q. Pi is equal to 22 by 7. 22 by 7 is 3.14 and so on. This is an infinite value and not written in the form of p by q. Rational number can be written in the form of p by q and q not equals to 0. For example, under root 4, 9 and 16. Ratio word derived from rational number. It means m ratio n equals to m by n. This is a fractional form. So when we take under root 4, we get 2 and denominator is 1. So it can be written in the form of ratio 2 ratio 1. Under root 9 equals to 3 and denominator is 1, 3 ratio 1. So this can be written in the form of p by q. These are the rational number. Real number are the union of rational and irrational number and denoted as r equals to q union q. This q denote the rational number and this q denote the irrational number. The next is terminating decimal. The terminating decimal, the decimal fraction in which number of digits after decimal point are infinite, or while converting common fraction into decimal fraction the division process ends, then it is called terminating decimal fraction. Terminating decimal fraction can also be converted in the form of p by q. For example, 9 by 4 is a fraction and we convert this fraction into decimal. We divide 9 by 4, 4 to the 8, subtract 8 from 9, we get 1. 1 is smaller value than 4, so we put a point here and get 0. Then 4 to the 8, subtract 8 from 10, we get 2. 2 is also a lesser amount than 4. We put point, so we get another 0 and value becomes 20. And then in table of 4, 4 5s are 20, so there is no remainder here. And this is the answer, which is an decimal value. So a fraction is converted into a decimal value. The next is non-terminating with repeating and non-repeating decimal fraction. The decimal fraction in which number of digits after decimal point are infinite, or while converting a common fraction into a decimal fraction, the division process does not end and none of the digit is being repeated, then it is called non-terminating and non-repeating decimal fraction. For example, we convert common fraction 1 by 9 to decimal. We divided 1 by 9. So 1 is a smaller value than 9. We put 0 for smaller value and then point to get zeros. We get zeros and then the value becomes 10. 9 ones are 9. Subtract 9 from 10, we get 1. 1 is a smaller value than 9. So we get another 0. And then 9 ones are 9. Subtract 9 from 10, we get 1. Then we get another 0 from upward. 9 ones are 9. Subtract 9 from 10, we get 1. And this process is continue. So this is a non-terminating and repeating, because 1 is repeated in the answer. This is a repeating, and non-terminating because this is a infinite value. Next example, we convert 9 by 7, which is a fraction, into a decimal. So we divide 9 by 7 and get an infinite value. These dots shows that this is an infinite value and repeating value. Exercise 2.1, question number 1, convert the following rational number into decimal fraction and separate terminating and non-terminating decimal. So the second part, 3 by 5, we divide 3 by 5 to convert this fraction into decimal. So when we divide 3 by 5, 3 is smaller than 5. So we put a 0 here for smaller value and then point to get 0. And now this value becomes 30. 5, 6 is 30. So 0.6 is the answer, and this is not a infinite value. So 3 by 5 equals to 0.6. This is a fraction and this is a decimal fraction. 3 by 5 is a terminating because this is not an infinite value. The next value is 2 by 7. We divide 2 by 7. 2 is a smaller than 7. So we put 0 for smaller value and then point to get 0. Now this value becomes 20. 7 2s are 14, which is smaller than 20. So we subtract 14 from 20 and get 6. 6 is less than 7. So we get another 0 and this becomes 60. So 7 8s are 56. We subtract 56 from 60 and we get 4. 4 is also an less amount than 7. So we put another 0 and this is become 40. 7 5s are 35. We subtract 35 from 40 and get 5. This value not goes, and so this is an infinite value and we get 0.285 and so on. So 2 by 7 is a non-terminating decimal fraction. In the next question we have 8 by 5. So we divide 8 by 5. 8 is greater than 5. So there is no need to put a 0 here. 5 ones are 5. We subtract 5 from 8 and get 3. 3 is a smaller amount than 5. We put a point and then get 0 and it becomes 30. So 5 6 are 30. There is no remainder we have. So this is the answer, which is terminating decimal fraction. Exercise 2.1, question number 2, convert the following rational numbers into decimal fraction and separate the repeating and non-repeating decimal. The first part is 3 by 7. We divide 3 by 7. So 3 is a lesser amount than 7. We put 0 here for smaller value and then point to get 0. 7 4s are 28. We subtract 28 from 30 and get 2. 2 is smaller amount than 7. So we get another 0. It becomes 20. Then 7 2s are 14. We subtract 14 from 20 and get 6. 6 is also a lesser amount than 7. We put another 0. 7 8s are 56. We subtract 56 from 60 and get 4. 4 is a lesser amount than 7. We put another 0. Here it becomes 40. Then 7 5s are 35. We subtract 35 from 40 and get 5. 5 is less than 7. So we get another 0 and it becomes 50. 7 7s are 49. We subtract 49 from 50 and get 1. 1 is lesser amount than 7. We put another 0 and it becomes 10. So 7 1s are 7 and We subtract 7 from 10 and get 3. 3 is less than 7, so we get another 0 and value becomes 30. 7 4s are 28. We subtract 28 from 30 and get 2. You see that the values are now repeating because we have already 4 and 2 and then 4 and 2 and then so on. It means that the values are repeating, so this is an repeating decimal and infinite, which is non-terminating value. The next question, we have 6 by 8 fraction. So we divide 6 by 8. 6 is a smaller amount than 8, so we put 0 here for smaller value and then point to get 0. So the value is 60. 8 7s are 56. We subtract 56 from 60 and get 4. 4 is a smaller amount than 8, so we put another 0 and this value becomes 40. 8 5s are 40 and there is no remainder here, so 0.75 is a non-repeating. In the next question, we have fraction 1 by 7. We divide 1 by 7. 1 is a smaller amount, so we put 0 here and point to get 0. So now the value becomes 10. 7 1s are 7. Subtract 7 from 10 and get 3. 3 is a smaller amount than 7, so we get another 0 and value becomes 30. 7 4s are 28. Subtract 28 from 30 and get 2. 2 is a smaller amount than 7, so we get another 0. The value becomes 20. 7 2s are 14. Subtract 14 from 20 and get 6. 6 is a lesser amount than 7, so we put another 0. The value becomes 60. So 7 8s are 56. Subtract 56 from 60 and get 4. 4 is a smaller amount than 7, so we put another 0 and value becomes 40. 7 5s are 35. Subtract 35 from 40 and get 5. 5 is a smaller amount than 7, so we put another 0. 7 7s are 49 and we get 1. 1 is a smaller amount, so we put another 0 and value becomes 10. So the values are repeating, so this is a repeating decimal. The next is 25 by 8. 25 divided by 8. 25 is greater than 8, so there is no need to put 0 here. 8 3s are 24. Subtract 24 from 25 and get 1. 1 is a smaller amount, so we put point to get 0. And then 8 1s are 8. Subtract 8 from 10 and get 2. 2 is a smaller amount than 8, so we put another 0 here and value becomes 20. 8 2s are 16. Subtract 16 from 20 and get 4. 4 is a lesser amount than 8, so we put 0 here and value becomes 40. 8 5s are 40. This is an non-repeating value because the value is not repeated in the answer. The next question is 13 by 4. We divided 13 by 4. 13 is a greater value than 4, so there is no need to put 0 here. 4 3s are 12 and subtract 12 from 13, get 1. 1 is a smaller value than 4, so we put a point here to get 0. 4 2s are 8. Subtract 8 from 10, get 2. 2 is smaller amount than 4, so put another 0 and value becomes 20. 4 5s are 20. The answer is 3.25, so this is a non-repeating value. The next is 29 by 2. We divide 29 by 2. 29 is a greater amount than 2, so there is no need to put 0 here. 2 1s are 2. Subtract 2 from 2 and the answer is 0. And then put 9 here. 2 4s are 8. Subtract 8 from 9 and get 1. So 1 is a smaller amount than 2. Put a point here and get 0. 2 5s are 10. There is no repeating value, so this is a non-repeating. So next, 10 divided by 3. 10 is a greater amount than 3, so there is no need to put a 0 here. 3 3s are 9. Subtract 9 from 10 and get 1. 1 is a smaller amount than 3, so we put a point here to get 0. 3 3s are 9 and then subtract 9 from 10 and get 1. 3 is a repeating decimal in this question, so 10 by 3 is a repeating decimal. Okay students, Allah Hafiz.